Well, hello, CP Math 1. This is Mr. Roberts, and unfortunately, this is a second recording for this video because I inadvertently turned off my microphone during the first round. So, in question A20, and by the way, this is the appendix, we're doing questions 20 through 25. This first question says, write and simplify the algebraic expression shown in each expression mat below. So, A here is an expression mat, and a reminder in this textbook, when we see regions that are shaded in, that represents a positive value. And if it's not shaded in, that represents a negative value. So you can see we've got here a positive one or a negative one. Again, shaded would be positive x. This is positive x, and these are three negative ones. So when I see an expression mat, there's a part that is not in parentheses and then a part that is. So I look at this and I say, oh, this is a positive 2x minus the number 3, and then minus the quantity. Now, what goes in these parentheses, right, is going to be what lives inside of the lower half of the expression mat, this negative portion. And, my goodness, this is going crazy here. And inside of that, there is a positive x and a positive 1. So if I look very closely, this is shaded in. It's a positive 1, a positive x, and this is a positive 1. But they live in the negative part of the expression mat, so it's negative this quantity. Now, it turns out if I want to move things from the negative, the lower half of an expression mat, to the upper half, I just have to change their signs. So I could move this up, and this would become a plus 1. And I could move this up, and it would become a plus x. It would become oh no, they're positive right now. If I move them up, it would become a negative 1, and this would become a negative x. And you can see that with the parentheses, right? If I distribute this negative to both of the terms inside, I end up with 2x minus 3 minus x minus 1. And I can simplify this. If we look closely, we do have a negative 2x, a positive 2x and a negative x. And we also have a negative 3 and a negative 1. So if I combine my like terms, right, the things that are the same, right, the same shape in this case, I would have a 2x minus x is just a single x, and a negative 3 minus 1 would be minus 4. So expression A is x minus 4. Let's look at mat B. Mat B doesn't have anything below. And if I just wrote everything out exactly as it appears, get away, as it appears, I would see, well, I see there's a positive y and there's a negative y. I see that there's a positive 3, and I see that there's a negative 1, right? Well, one of the things we know is that if we take things that are opposites of each other, they make 0. So I can group up this negative 1 and positive 1. That's gone. This negative y, right? The one that is negative y and positive y, if I pair those up, those are gone as well. Let me do that. So we're literally left with just the number 2, right? A positive y, negative y is 0, and then 3 minus 1 is equal to 2. So this entire expression mat is just the number 2, and you can see the 2 are those two positive values that are left over there. The final mat is this. We have a negative x that's living in the positive portion of the mat, and then we have, that is a negative x. Then we have a minus, a positive x, and then plus 2. Okay. Again, if I want to move something from the negative portion of the mat up to the positive portion of the mat, this would become a negative x. And if these two moved up, they would become a negative 2, right? Same thing I can see here. This becomes a negative x, and it becomes a negative 2. So this expression is equivalent to negative x minus another x, and then minus 2, or negative 2x minus 2. That's what this mat simplifies to. right, let's go on to question 21. 21 says, let me zoom out. It says, for each expression below, first indicate how many terms it contains, then copy and simplify each expression by combining like terms. Algebra tiles may be helpful. So let's just go through the first step real quick. Identify the number of terms. So just counting the number of terms. This first one has 1, 2, 3, 4, 5. This has 6 terms. Some of the terms are like terms, right? Some of them are not, but that expression has 6 terms. If I look at B, it has 1, 2, 3, 4, 5, 6, 7 terms. 7 terms. Again, some of them may be like terms, some of them may not be. C has 1, 2, 3, 4, 5, 6 terms. And let me guess, this one's going to have 7? No. 1, 2, 3, 4, 5. It does have 7 terms. However, I can see that clearly some of those are going to go away because one of them is the number 0. All right, so let's go through now and simplify. So let's take a look at this one that had 6 terms. And I'm going to just kind of group up some things that are like terms just based on some color. So if I look at this, I'll highlight them. I see that I have X terms, right? And these would look like the X rectangles if I was using algebra tiles. So there's a 2X, a negative 3X, and way down here there's an X. Now if I combine those X tiles, I have 2 minus 3X, which would be negative X, and negative X plus one more X down here. That's going to be no X's. So those actually are going to be gone from the expression, the final expression. The next thing that I see is there is this 4x squared term, so I'll write that. There is a 4x squared. And then the final thing that I have available is there is a negative 3 and a positive 10. And if we take negative 3 and add 10 to it, it's going to give us a positive 7. So I believe this becomes 4x squared plus 7. 4x squared plus 7. Let's look at part B. Again, there are 7 terms originally here. Some of them are like terms, I hope. I do have x's. Here's x's, x's. There's an x. I have some y squared terms. Here's a y squared, a y squared. And then I have some constants, right? I have the number negative 9, and I have the number positive 9. So if I combine up my x's first, I see I have a negative 4x minus another x, which would be negative 5x. And then plus 3x should give me negative 2x. So that's a 4, and 1 is 5 minus 3 is negative 2x. And the other thing that we have is a y squared minus 4y squared. That looks like minus 3y squared. Right? And if I was looking at the algebra tiles, I could see that 4 of them are negative. One of those negative ones would combine with this one that's positive, and I would be left over with 3 of the negative tiles. And the last thing that I have here is a negative 9 plus 10, which should be plus 1. Probably the way this would be written in the textbook would be negative 3y squared, and then minus 2x, and then plus a 1. Let's go on to part C. Again, C had 6 terms originally. That was part of the question. But now let's go ahead and get rid of those terms. So let's kind of group these together. I do see that I have a 2x squared, a 3x squared, and a 4x squared. I also have that's interesting, a positive 30y and a negative y. And the other thing I have is this one x tile that's all by itself. Which I've run out of. I'll just. No, that's a terrible color. I can't see that, which is just this one. So what are we looking at? We're looking at 2x squared plus 4 more x squares, which would be 6 of them. So I've got a 6x squared. 30y minus y looks like plus 29y. And then the last part here is just going to be a minus x. That should be part C. By the way, you can see I went from 6 terms down to just 3 terms because I was able to collect up the like terms. And then our last one is D. let's collect up all the parts we have. So we have some parts. I see a 0 and a -20, and I see a +10. Those are all like terms. Those are just unit tiles. There is a negative 5x squared. I'm sorry, there's a negative 5xy, and there is a positive xy, just one of them. Also, we have a 4y squared, and we have this little negative y all by itself. So if we start pulling together our like terms, let's go with the 4y squared first. So I'm going to say there is a 4y squared. Next, let's go for the xy's. I've got negative 5xy plus 1, which would make negative 4xy. The next thing I've got is a negative 20 plus 10. The 0 doesn't matter, so negative 20 plus 10 is going to make a negative 10. And then we're going to finish this off with the negative y that's left over. So we went from 7 terms down to 4. For question, what is this, 22? We're given the function f of x equals 2x plus 3, and we're asked to evaluate that for different inputs. So again, in function notation, right, f of x equals 2 times some input x and then plus 3. So here's the deal. If I want to figure out what f of -5 is, if that's my input, everywhere that I see x inside the original expression, I'm going to replace that with a -5. So the expression I'm evaluating is 2 times -5 plus 3. So 2 times -5 is -10 plus 3 more. -10 plus 3 would be a -7. So what's happening here is when this function receives the number -5, it gives me back -7. -5 goes in, and -7 comes out. Let's do the same thing for the next input, f of -1/2. So again, that becomes 2 times the -1/2, right? 2 times the input, and then plus 3 more. If I double -1/2, that's just going to become the number -1. Plus 3 more is going to equal +2. So again, the idea is that when -1/2 is my input, -2 becomes the output. Just like when -5 was the input, -7 became the output. Next, let's look at what do I get if I put 4 into this function. Again, what does this function say? It says double your input and add 3, right? That's what, when I see that's what I say, right? It says, hey, double your input and then add 3. So let's do that. So if 4 goes in, I double that input. That's going to become 2 times 4. And then don't forget the plus 3. So this becomes 8 plus 3, 8, 9, 10, 11, which is 11. So when 4 goes in, 11 comes out of that function. And the final one says, what is f of -2? So if we place 2 into the function, whose rule is double the input and add 3, there you can see I did it, right? I'm doubling the input. This is going to become -4 plus 3. Looks like we're getting a -1. So in each case, we get an output. Here's an output of -1, an output of 11, an output of -2, an output of 7. And each one of those outputs were generated by using the given inputs, right? -5 gave me -7, -1/2 gave me -2, -4 produced 11, and -2 produced 1. All right, let's go to question 23. 23, this icon really indicates, hey, let's just do this no calculator, and let's see what works and what doesn't work. So it does mention earlier reviewing the math notes section book on order of operations. So if that's a thing, the math notes section, if you want to review order of operation, you might do that. We're going to kind of talk about it here. The idea is that certain operations have precedence when I'm looking at an expression, right? So for example, grouping symbols are first in precedence. Then we have exponentiation, or raising things to a power. Then we have next multiplication and division from left to right. And then finally addition and subtraction from left to right. When I look at this first expression, what I see is a multiplication problem, right? I can see that there is this -2 times -5. -2 times -5. And I need to evaluate that first. Well, it turns out when I multiply -2 times -5, I get 10. And I get positive 10, actually, right? -2 times -5 is positive 10. So this is going to become 7 plus that 10, or 17. So this expression is equivalent to 17. Let's do them in this order. So I'm going to go to C next. C has exponentiation followed, and then there's some multiplication also. As far as the exponent goes, I'm multiplying a -3 times a -3. So I might go ahead and write this -5 times a -3 times a -3. At this point, I would get the same answer because it's just all multiplication now, but I'm going to go ahead and finish off this exponentiation part. Right, -3 times -3 is a positive 9. This becomes 5 times 9, which is 45. So we end up with the number 45 there. And then the last part, well, in this column anyways, is C. And you can see there's a -3 times a 4, and there is a 5 times a -2, and we're going to add these two quantities once we've completed the multiplication. -3 times 4 is -12. 5 times -2 is -10. And when I combine those, I should get -22. I believe this is, please leave a comment below if that's not correct. -12 plus -10 looks like -22. All right, and then over here, these three, let's look at B first. Ooh, I do have some exponentiation, but before I do that, I need to know, well, what specifically am I raising to the second power? And it turns out it's 7 minus 6. That's right, -3 times 2 is -6. And 7 minus 6 is exactly the number 1. So what I've got here is this is 6 plus 3 times 1 squared. 1 squared is the number 1. 3 times 1 is 1. So this is just 6 plus 3, or 9. 35. Okay, so big picture, I see division and multiplication from left to right, but I need to know what this thing is right here so I know what to divide by and then what to multiply by. But once I figure out this thing that's in the parentheses, I'm just going to go from left to right. 16, let's see, this is interesting. This is 16 minus 9. Why is it -9? Well, it's because that 3 is just, squared, and this ends up being the opposite of 3 squared, right? It's not some negative number squared. It's just minus what 3 squared is. 16 minus 9 is, what is that, 7? 16 minus 9 is 7, I think. So this problem becomes 35 divided by 7 times 2. Let's see, 35 divided by 7. Pretty sure that's the number 5, right? 5 times 7 is 35. 35 divided by 7 is 5 times 2. Looks like we've got 10 for part D. Final one, part F. Oh my goodness. I'm feeling the fatigue. So there is a division problem, right? Big picture is I've got this thing, and I'm going to divide that by 4. And then once I know that what that is, I'm going to add a 7 to it. There's a 7 that's going to be tacked on. So what's in the parentheses here? I've got 10 minus the number 8, right? 10 minus 4 times 2, 10 minus 8. So I've got a -6 times 10 minus 6, 10 minus 8, which is 2. And -6 times 2 is -12. So what I have here is 7 minus 12 divided by 4. But you see it, it's true. I've got to take this negative 12 and divide that by 4. Negative 12 divided by 4 is 3. So we are looking at 7 plus 3. Really? Not positive 3. Negative 12 divided by 4 is negative 3. That's 7 minus 3, which produces an answer of 4. I think F is 4. For question 24, we're asked to sketch these things on our graph paper real quickly. You don't have to go crazy about it. Then we're supposed to calculate the area and perimeter of each shape, assuming that all corners are right angles. So I think I'm just going to do just this first one only and leave the other one for you. The perimeter is the sum of several pieces, right? The perimeter is a 25, plus 16, plus 12, plus 19, plus 13, plus 35. So that would be the perimeter. And there's no icon saying don't use a calculator, so I'm going to use one. 16 plus 12 plus 19 plus 13 plus 35 plus 25. I got 120. So I believe the perimeter is 120. And the units of measure are not specified, so I'm just going to say 120 units. And again, this is the perimeter. The distance around it, if I was to walk around it, the perimeter is 120 units. In terms of area, I'm probably going to dissect this by looking at these two rectangles. One of the rectangles is 16 by 25. I could find that area by just multiplying. And the other rectangle looks like it has an area of 19 by 13. So if I combine, let's see, 16 times 25 is 400. And I'm going to add to that 19 times 13, which is 247. So if I combine those, I get an area of 647. And because I'm multiplying units by units in each case, right, at 16 units times 25 units, units times units is units squared. So the area would be, if those were inches, it would be 647 square inches. If they were miles, it'd be 647 square miles. So those are the units. B, I'm not going to do. I'll look at this one in class and see how you did on it. But get out of here. What's going on? Yeah, so go ahead and take a look at and do part B. All right, we're on to our last question then, and it is 25. It's interesting. 27 says don't use a calculator, but then they do say check your work with a calculator. The classroom calculators do a phenomenal job of this, but I'll talk about what you could see on some other calculators. So let's begin. I'm going to reorder these things. So big picture, what's going on here is there's 1, 2, 3, 4 different numbers that are being multiplied. And because of the commutative property, right, I can reorder or commute these terms or factors rather, and I can get the same product. So I'm going to choose to look at this as 1.75 times a 6.01 times 10 to the 20th power times 10 to the 14th power. These things immediately, right, because these are factors of 10, I have a base of 10 and different numbers of factors. 20 of them times 14 more of them is going to give me 10 to the 34th power. Now, in terms of the product of these other two numbers, they're asking, I want to do that part with a calculator. I'm weak. 1.75 times 6.01. What do I get? Oh my goodness. I get this 10.5175 times that. Now, this number is not in scientific notation. And the reason is because the decimal's in the wrong spot, right? So I can modify this. I can write 1.05175. Now, I'm going to multiply that by one factor of 10. And my thinking here is that this thing that I just wrote down, right? The 1.05175. If I multiply that by 10, I would get exactly this thing. So the two things that are underlined are identical to each other. What's nice is the decimal is now in the right place, right, for this to be in scientific notation. And then I have to multiply that by the 34 additional factors of 10. So my final answer in scientific notation would be 1.05175 times 10 to the 35th power. So the classroom calculators will give you exactly that answer, but you might be using a different calculator. And I just want you to see what's a possibility. If you do this problem in your calculator, you could quite easily see this as an answer, 1.05175, and then you would see an E, and then the number 35. So if you see that, what this indicates is this E, right, should be replaced with times 10, and then this number 35 should be the exponent, right? So this notation shows up on some older calculators, and I just hope that you're aware of the fact that this times 10 to the 35th power is the same thing as this E35. All right, that's it for the assignment, and I think I'm under 30 minutes. I'll talk to you later.